Hey everyone. Good morning, good afternoon, good evening to where you are around the world. We're going to be getting started here in just a few minutes. We'll give everyone a few minutes to join in and get settled. You have a few minutes to get that last cup of coffee or beverage of your choice, and we'll get started here in just a few minutes. So we're excited for today's webinar. Again, we see attendees joining from all over the world. We'll get started here in just a few minutes, and we'll let you know. Started in about 1 minute here. Okay, well, it's 1 minute after the hour. I think we'll go ahead and get started. Welcome, everyone. Again, good morning, good afternoon, good evening to everywhere you are around the world. We're seeing in the chat right now, say hi, say where you're from. This is really exciting. We're really excited about today's webinar and today's content. Today, we're going to be talking about storage and applications in Kubernetes. And I'm your host for today's webinar. My name is Adam Berg. I'm with Kasten by Veeam. And our two presenters today are Thomas Keenan, Senior Product Marketing Manager for Kasten by Veeam, and Michael Matson from HPE, who is a technical marketing engineer who's going to be talking all about storage and Kubernetes. A little bit of housekeeping for today's webinar, please. Save your questions for chat. So there is a Q&A function. We'll get to all your questions at the end of today's presentation. And stick around for the end. We're going to be giving away a $200 Amazon gift card to one lucky participant, but you have to stay all the way to the end to win that prize. So let's, without further ado, let's go ahead and get started here. Just real quick, here is our quick highlight, agenda highlight here. We're going to be talking about Kubernetes and crossing the chasm and Kubernetes storage challenges. And then we'll get into protecting Kubernetes applications and some of those requirements, persistent storage in Kubernetes, how to run stateful workloads. And again, we're going to be talking about learning.kasten.io and exactly what that is for all your learning needs. So without further ado, we'll pass it over to Thomas. Thomas, go ahead.
Hey, Adam, thank you very much for the kind introduction. And as Adam mentioned, good morning, good evening, good night, wherever you might be. We appreciate you joining today. So I thought I would kick off the webinar by summarizing a very interesting and timely survey by the Cloud Native Computing Foundation, which uses its unique position in the cloud native space to survey the landscape, understand market dynamics, and better serve users of open source cloud native technology. So they are very much everything cloud native. The survey was released in early February. If you've not had a chance to download a copy, you definitely should. The survey is conducted annually, and this year there were over 3,800 participants, which is over 10x. It's grown in a very short number of years, and it covered many topics of interest to the community. From a Kubernetes perspective, the survey confirms what a lot of us have been thinking, that Kubernetes has crossed the chasm into mainstream use. So 96% of those polled indicated they were either using Kubernetes or evaluating it. So when we are in webinars like this, we're in the right place. It's a very important IT initiative, Kubernetes is, more than ever, and we need to understand K8 structure, use cases, applications, and from our webinar, obviously, backup, disaster recovery, and storage. Might I say that a great place to get that education about Kubernetes is learning.kasten.io, which Kasten launched at KubeCon last October in response to the community's desire for more education, and which I will discuss in more detail in the webinar later on today. Okay, so let's look, again, if you're new to Kubernetes, you may be wondering how fundamentally Kubernetes storage is different than maybe some of the storage you're used to and what the top challenges are in using it. Containers are designed natively to be transient and ephemeral, so they can be spun up and down quickly according to enterprise workflows. And Kubernetes enables rapid scaling of production containers to accommodate a large number of users. However, scaling the containers with traditional storage, which you may be used to, can pose some challenges, and I'm enumerating 3 right here. Number 1, most of the traditional storage solutions available right now statically map to a cluster and are hard to assign to containerized workloads. Storage is assigned during the creation of hosts and stays consistent during the lifetime of the host. So very much a static setup. While reassigning, number 2, storage volumes to hosts or clusters, that's possible. The design and architecture do not provide workload mobility. So traditional storage in general is unsuitable for elastic resource scaling and automated provisioning required in Kubernetes workloads. And finally, number 3, Kubernetes also promotes an automated approach to almost everything, whether it's requesting new storage, changing the storage size, dynamic mapping to different storage volumes, and many other functions. So traditional storage solutions were never really built to support these workflows or continuous changes in storage configuration and provisioning. Okay, so having had that groundwork, given all of this, what are the key requirements for protecting Kubernetes? Let me go through those. More and more containers are being used for stateful applications and generate lots of data and persistent storage. And as soon as we talk about having lots of data, we need to ensure we protect that critical data for failures and disasters. And we put the backup to work by using it in a test dev environment. So here are the key requirements in protecting containers applications, including Kubernetes. They include, number 1, we need seamless operations and policies both on-prem and in the cloud, as obviously applications and containers can reside in either or both locations. We need granular application-centric protection. That is, we need to be able to auto-discover all application components running in a cluster to understand how to protect it. And then finally, we need fully automated restores to correspond to the automation needs of the Kubernetes environment. And finally, the ability to perform dynamic provisioning, snapshots, clones, and restores. So at this point, Adam, I'd like to pass it to Mike and back to yourself, and we'll talk somewhat about persistent storage.
Yeah, so thank you, Thomas, for that quick intro to storage and Kubernetes. Now, I'd like to bring in Michael and from HPE, who knows a little bit something about storage and Kubernetes. Michael, let's talk about persistent storage and Kubernetes. What can you, from your perspective, being at a storage vendor, give us a little maybe history of the persistent storage and Kubernetes, if you would.
I certainly will, Adam. Thank you so much, Adam and Thomas, for inviting me to this webinar. I'm going to talk about persistent storage in Kubernetes and a little bit about what you should think about when you deploy stateful workloads on Kubernetes and some of the parameters around that. I think it's important to kind of understand a little bit about the history, how we got here, right? So since the big 1.0 of Kubernetes, there's been numerous in-tree storage plugin that we kind of have up to this day, right? But at that point in time, it was very difficult for third-party vendors to integrate their storage systems into Kubernetes because you had to be part of the upstream Kubernetes project. So what we got there was this little shim plugin, still an upstream plugin, but it allowed vendors to write something called flex volume drivers. These flex volume drivers were basically a single binary. You dropped it on a host, and it was very difficult to to scale and to add APIs to that particular plugin. So that has been deprecated now. So what happened was it was a consortium of different companies that basically came together and wrote something called the container storage interface specification. And it's a system to allow storage orchestration for a container orchestration. And the big difference here is that this specification is managed outside of the realm of Kubernetes, and it's its own standalone project. The CSI drivers themselves, they are deployed like any workload and managed like any workload on top of Kubernetes, which allows users to deploy drivers from various vendors and cloud providers and such in a very easy and seamless way. So looking at CSI drivers in general, right? So I took a snapshot of the current list of CSI drivers the other day here, right? So we have 95 documented CSI drivers, and that is actually quite a lot, right? So I want to give you a few parameters on how to select a storage solution for your particular problem, or more or less like a laundry list of things that you should think about, right? And provisioning volume can be done dynamically, it can be done inline, it can be statically. So what do you need, right? The PVC requesting the persistent storage, what kind of access mode does it need? Do you need raw block? Do you need file system? Or are you going to run a distributed storage solution on top of this storage solution itself in Kubernetes? Those are the things that you need to think about if you want to have a file or block. You want to be able to expand your volumes. It's statically provision a 10 gig volume when you grow to 20 gig. You want to be able to do that pretty seamlessly from an end user perspective. You also need to think about like what kind of capacity you're looking at, both from a performance and scaling perspective, and make sure that you can attach as many persistent volumes to your cluster nodes as your workload requires. Kasten has an excellent utility there called Kubester that allows you to evaluate just that. You need to understand if your application is being deployed in the public cloud in different availability zone and you're running applications that require topology support, that needs to trickle down all the way to the storage driver to understand those topology keys. Being able to protect your application from a cloud native perspective, the CSI driver needs to support snapshot clones and being able to do restores from those clones to be able to use market-leading utilities such as Kasten K10 to perform those operations from a cloud-native perspective. If you're running Windows containers, yep, the CSI driver needs to support Windows. Some customers care a lot about if the driver is open source. Does it have a strong community? Is it well documented? Those are very important parameters when you evaluate CSI drivers as well. Some customers, they have selected a certain Kubernetes ecosystem, such as OpenShift or Rancher and such, and then you need to kind of look at that particular vendor's ecosystem. Is the CSI driver certified? Do I need some other kind of tweaks to do to my storage system to make it work, right? And that is also something that's important. Observability and metrics, yes, can I meter my storage utilization and capacity? Can I track that? Can I plot that, the trending in Grafana and such? Not all drivers export Prometheus metrics, and that's something that you might want to look at as well. Last but not least, security, encryption, multi-tenancy. Those are things that you need to think about if you're trying to provide a storage solution to multiple clusters, probably traversing insecure networks, what kind of constructs are available, and can I actually use my CSI driver with multiple Kubernetes clusters at the same time? So that's the CSI part. Now we want to talk a little bit about the volume type. So this is more like an educational thing, what we can expect when we deploy persistent storage and ephemeral storage in Kubernetes, right? So the persistent volumes that basically live beyond the life cycle of the pod, they can come from a cloud provider, either via a disk or a file system. It could be traditional NAS storage, NFS, iSCSI, fiber channel, NVMe over Fabric is something that is up and coming as well. And it can also be provided directly from the nodes themselves. You can use the in-tree vendors and also the CSI drivers that I just talked about. So if we look at ephemeral volumes, the most prominent one is the local file system provided by MTDIR, right? But you can also have CSI drivers that support CSI ephemeral volumes and generic ephemeral volumes that it's provided by any driver basically that can do dynamic provisioning. And the thing with ephemeral volumes is that if you reboot your pod, or if your pod gets rescheduled or upgraded or rolled back and such, the storage resources associated will be destroyed and recreated. So you will always start from a known state. And the third one here is the projected volumes. And that's basically where you can combine resources within Kubernetes to create a virtual file system structure with resources such as a config map, service account token, a secret download API and such, and have your application running inside a container interact with these resources all available to you in Kubernetes. So the access mode that I mentioned in the CSI driver list is something that is very important depending on what kind of application you want to run, right? So if you look at traditional cloud native workloads that are deployed in a shared nothing distributed architecture, they leverage something called a stateful set. And that stateful set usually leverages a read-write once volume, where one volume is dynamically provisioned for each replica in the stateful set. And you will find the usual suspects there, like the MongoDB, MinIO, Kafka, MySQL, Rook, Redis, etc. And the deployment controller in Kubernetes is very practical for the single instance where you have applications that are of the legacy type, right? You have some enterprise app somebody wrote 20 years ago, and now you're lifting and shifting that into a container. And that means that you will have a read-write once replica of that particular deployment running at only one at a time to prevent split brain scenarios. But if you want to have multiple replicas accessing the same data, you need to think about the read-write many access mode, which allows scalable distributed applications with shared storage. And the last one here is read-only many, which provides an excellent way to provide content serving. There's also a new access mode called read-write once pod, but we're not going to talk about that today. It's currently in alpha. So I'm going to switch over to the fireside chat. Do you want to say a few things there?
Yeah, so that was amazing. That was a good sort of primer into CSI. So let's have a little chat. What does this actually look like in production, right? I think a lot of customers, they sort of have a fundamental understanding of what CSI does. Help us understand, or help the audience understand, how are we supposed to run stateful workloads in production with enterprise class storage on premises, for example?
Yes, absolutely. So what I usually do is that I look at the application itself, right? So what kind of so say in this particular example, I'm going to use MongoDB as an example, right? It's a NoSQL database that requires a lot of persistent storage being provisioned dynamically from the cluster. And most of these applications, they have some sort of best practice on how to deploy the application, right? So I took this diagram from the operator, the MongoDB operator, and you can see that it kind of laid out the object quite nice for us here. You can see there is a stateful set being, the application is controlled by a stateful set controller that require persistent volumes, and it's being dynamically provisioned from our storage class, right? And I can immediately kind of translate this to my little architecture diagram there that, yeah, this kind of fits the shared nothing distributed application paradigm, right? So now we have all these components laid out. I know exactly how this application runs on Kubernetes and what I need to think about when it comes to storage. So breaking it down a little bit further here, let's put the application in the center here. So I know what we're running a stateful set with read-write once persistent volume claims. They need to be attached to a host somewhere. And where should we provision the storage from? Should it be a local disk? Should it be a cloud provider? Or should it be an external appliance or an appliance running on Kubernetes itself, for that matter? But in this example, so let's just keep the Kubernetes cluster standalone and have the volumes externally to the cluster in this particular example. So then you kind of need to start breaking it down from the top here, right? So what kind of settings do I have available to me within the MongoDB operator, or if you might deploy it through a Helm chart? how do I tailor this for my use case? How can I get the right type of performance and throughput? How can I scale the app, et cetera, et cetera? And you might want to look at other kind of resource quotas, the RBAC. Can I deploy this application as a user, or do I need some admin privileges to spin it up, et cetera? And also looking at the nodes themselves, you need to meet a certain performance envelope for your application in terms of how much data you're putting through their paces, and how you can distribute the load across these nodes, right? So most of these stateful sets that you deploy, they have some sort of anti-affinity rules, right? So, and that's good. So you can kind of size your instances accordingly, because you know that there will only be one replica running per node at any given time. Looking at the storage layer there, you need to ensure that the CSI driver supports the topology of your Kubernetes cluster to ensure that storage is provisioned locally to where the application is running. Does it meet your performance needs? Do you need to deploy this on a spinning disk, or do I need flash? Do I need in-memory? Do I need to figure out how to grow and scale my application from the initial footprint of the application towards growing it into a large production database in this case? And these are things that we kind of think about day one, right? So we have our cluster stood up, we have our application deployed, and then we need to kind of go into a mode where everything is up and running and everything's good, right? And then we kind of need to figure out how to handle this in a day two scenario, right? So how do I perform upgrades and rollbacks? How do I protect the data and the configuration of my application? As you know, deploying an application on Kubernetes, there's various controllers involved. There's many API resources that comprise the application. It could be a config map, it could be a persistent volume claim, and all these things, right? And they need to be, and they are usually altered during runtime, right? So even if you have the original manifests, they might not apply after you've run the application for a while, right? So that needs to be continuously protected. And that brings us into the recoverability, the RTOs and the RPOs, right? How long can you have an outage, and how high resolution do you need in the recovery procedures? Like, how much data can you essentially lose? Do you want to use this application for auxiliary use cases? And that most of the time we talk about test and dev, right? So how can you use your production data in integrate that into a CI/CD pipeline and use this for testing and staging, and let developers work on their feature branch with a production-like data set? We also need to think about the cluster lifecycle management. I usually see the deployment of a Kubernetes cluster, I kind of see it as a sliding window. You deploy your app, and you need to start thinking about how do you expand your nodes, how do you expand your cluster, how do you upgrade a cluster, right? And how do you migrate your app, right? So you might come to a fork in the road where you need to lift and shift your application from one Kubernetes cluster to another, right? So how do you plan for that? How do you have tooling for that, and so forth? And last but not least, like in the storage layer, like you need to think about the service and management, right? I've been in storage for way too long, and I know that things, they break continuously, right? It doesn't matter if it's a spinning disk or if it's solid state media. Storage is a troublesome thing, and how do you make sure that that is part of your cloud native workflows for managing the storage resources, even if it's from a cloud provider? And then you need to start thinking about the data integrity of your application. How do I ensure that the data that I once wrote is actually there? Which also brings another excellent point, right? Is the data portability. How can I actually copy out my data without preventing a vendor lock-in in a cloud native way, right? So those are the things we need to start having a frame of mind when we think about the day two operations of your stateful workloads in Kubernetes. And that was my last slide. And if you want to learn more about these things, you can visit hpe.com/storage/containers if you want to learn about what HPE does in this space. And over to you, Adam.
Wow, that was amazing, Michael. I really appreciate you breaking that down. Again, for all of those wondering, you will get a recording of this presentation. So in case you need to replay that, there was a lot of information flying there. That was amazing. Thank you. I want to switch back over to Thomas. Thomas, tell us about learning.caston.io and what that's all about.
Yeah, absolutely happy to do that, Adam. So looking at the history of learning.caston.io, and folks, if you hadn't had a chance yet, please go ahead and register and get involved in the community. It's a great resource. About a year ago, we did a lot of polling at KubeCon and realized while Kubernetes adoption was certainly occurring, the need for education was huge. And clearly, we've seen here today and in many other parallel Kubernetes learning experiences we've had, there's a lot of ground to cover in learning Kubernetes in general, and in this case, storage and applications specifically. So I want to remind everyone, we have created learning.caston.io to help you do exactly that. If you've been thinking about upping your Kubernetes game, this is the place to do it. There's no cost to either join or participate. As a matter of fact, if you do go ahead and join and would like to become an instructor, would like to suggest labs, would like to suggest other material we should cover, we'd love to hear from you either via email directly or via our Slack channel, and all of those details are available once you sign up. So whether you're a seasoned pro, you're a rookie, if you're something in between, all of those states are okay. You'll basically find with the learning.caston.io site a balance of Kubernetes theory and hands-on labs led by cloud-native subject matter experts. These are folks who really know their business. They've had years in the industry. They've done proof of concepts, and they come to us from many countries, many walks of life, many different approaches to Kubernetes. So we have a very nice cross-section of instructors. The other thing is that that distinguishes this site is it's not just a series of videos. We have divided into several labs where you get hands-on experience, not just about watching videos, not just about reading, but actually having hands-on Kubernetes commands that you can use. We also do have resources like additional ebooks, white papers, videos, and webinars to supplement our material. But again, I would say the heart, the soul, the pride of the site are the labs. Recognition for your progress occurs after every single one of the labs with digital badges, and we also have recently introduced a wall of fame. And you might ask exactly how do I get on that wall of fame? Well, it's by doing activities and taking labs. Each one of the labs is worth a certain number of points, and taking more labs, obviously getting more involved, get you additional rewards. We are also thinking strongly of hackathons and other types of contests, so keep on checking back often in order to see what's new, what's different on the learning.caston.io site. And the other thing I think is very important to mention is the interaction with the broader Kubernetes community that you're going to get, where you can get your questions answered directly by other subject matter experts in the industry. I mean, if you're a rookie and you're looking for a mentor, this would be a great place to find it, someone to answer your questions, especially if you're thinking about a long-term career in the Kubernetes space. It's a great place to meet new folks and to establish that sense of community. So having said all that, if you're ready to get started, head on over to learning.caston.io and begin your journey. We've got over 7,000 registered users who have taken just a plethora of labs, well over 3,000 last time I checked. And like I said, the labs cover a variety of different areas. The ones I have currently available are building your first cluster, which is a very basic skill set, building an application, backing up an application, application consistency, and obviously now the subject of this webinar, storage and applications in Kubernetes. We do churn out about one lab per month. So again, check back often on the details. And what we continue to do also is to refresh the content. There's new blogs. There's new commentary from various folks in the industry. We have a lot of folks blogging who bring different perspectives. So all that's great to see on the participation level. My most recent lab is Lab 5, which is the topic of this webinar, and that is obviously storage and applications in Kubernetes. It consists of the sections that you're seeing here, and that's explaining first, as I said, there's 30 minutes of theory and then 30 minutes of hands-on. And in this case, the theory covers storage classes, volume types, snapshots, general storage best practices, and then Kubernetes native backup and recovery with Cast and K10, where you'll actually be able to use an instance of Kasten K10 to do exactly that, as we explain storage terminology and get you for more hands-on. The other thing, like I said, that's very important is to realize you're going to be practicing real hands-on commands, and you'll be guided through those in the hands-on section. And again, it's balanced between about 30 minutes of theory and 30 minutes of hands-on. Again, there's a variety of links in the lab that are provided throughout. So if you want to take the lab, you look through our links and say, hey, those 2 or 3, Kubernetes.io links are really interesting. I'm going to deep dive on those. That's something you can certainly do offline, or you can even partially during the confines of the lab itself. Again, after each one of our labs, you'll be provided a different digital badge. You can share those on social media, on LinkedIn, Twitter, etc. And they're in a format that you can do exactly that. If you want to go on LinkedIn or Twitter and tell other folks how you've done in the labs and how you've badged, we've had a lot of folks do that. Again, if you'd like to participate, you get in, you register, and you get excited about the site. You want to go ahead and participate more fully. Hey, maybe even become an instructor. We are glad to take all comers. Go ahead and Slack us, email us. Volunteer as an instructor. Can be a light participation, or if you want to get more involved, we can talk a plan to get you involved as an instructor. So at this point, there's a quick summary of learning.kasten.io. Folks, go ahead, do register if you haven't, and take our labs. And at this point, Adam, I'll pass it back to you for a little time for Q&A. I think we've got maybe a minute.
I think we've got maybe a minute left to answer a couple of the questions live. Thank you, Thomas, again for that. Thank you, Michael. Amazing content today. I do want to get to a couple of questions that we didn't get to via chat. I think the first one comes in here for you, Thomas. What is the difference between the KubeCon labs that we took when we were out at the KubeCon conference in the fall and some of the longer labs that we find on learning.kasten.io?
Yeah, absolutely, Adam. So the principle of that was that the KubeCon lab, we realized that on the trade show floor at KubeCon, we were not going to have an hour with folks. We were probably going to have 15 or 20 minutes. And so we did a very brief lab to introduce some basic Kubernetes concepts and then get some quick hands-on where you could invoke and download K10 and do some backup recovery with that. Out of that then was an introduction to a variety of the other labs that we had at the time. We had 3 others. And so it was a great jumping off point. If you want to start now, the KubeCon lab is still available, and take a 20-minute lab just to get yourself customized to it and jump in at the, we'll call it the shallow end of the pool. Feel free to do so, and then graduate to our larger labs.
Great. And don't forget about the poll that's currently up here at the end. And I think we got time for one more question, and then I'll announce the winner of the gift card. And I think this last question should be for Michael. Michael, how would you choose, or why would you choose an external SAN solution for Kubernetes over, the plethora of what's called Kubernetes native storage solutions out there, or vice versa?
Yeah, that's an excellent question. It's a matter of keeping your different layers separate, right? So you want to use Kubernetes for compute, you want to keep your network separate, and you want to keep your storage separate, right? And it also allows you to port your applications between clusters more easily, because your data is not trapped in the cluster if you deploy your storage solution on top of the cluster, right? So with a new cluster, you would simply install the CSI driver, and you would be able to import the volumes from your external SAN solution without actually copying any data, right? And that matters if you got terabytes and terabytes and hundreds of applications to transfer one cluster to another.
All right. Well, we're getting to the end of our time. Our winner of our raffle today is Nitesh Singhal. Nitesh, congratulations. You are the winner of our $200 Amazon gift card. And I want to thank again our panelists today, Thomas Keenan from Kasten and Michael Madsen from HPE. I thank you all again. And thank you all for joining us on our journey today for learning.kasten.io and storage in Kubernetes. You all receive a copy of this recording emailed to you, and the recording will live on learning.kasten.io after the event. Have a great morning, afternoon, and evening, everyone.